You recording? Hello, Dr. Hector. I'm gonna go ahead and try to explain quantum model. I don't know how you say it, but I wanted to explain it in a way that's very simple, in a way that somebody that's not in our class would be able to understand it. Somebody that wanted to remember it, could remember it in a very easy way. So what I kind of describe it as is kind of like a person driving in a car. And the scenery kind of being like the film, and the car being the X-ray, how fast it's going, and also like the gas, like how many X-rays are being used and stuff like that. So I'm gonna go ahead and use this whiteboard to try to explain kind of like how I describe it so people can understand it again that wouldn't be in our class, that would want to ask us, and as well as anybody else that would want to know it in a little very simple way. So first I'm going to start off with high speed. Okay, so if we take a car, okay, and we're driving fast, okay. So imagine you're driving through a neighborhood and you're going kind of fast. So let's say you're going 55 even though you should be going like 25. So imagine you're going pretty fast in a neighborhood and you're seeing all these trees, right? You're seeing all these houses and stuff like that. And you won't be able to really see the detail, right, of the houses or the trees or anything that's around because you're going so fast, right? So now let's imagine that the gas is the amount of X-rays that are being used. When you're going fast, you use a very low amount of gas, okay? Which is a good thing. You don't want to be using up too much gas. You don't want to be using too much X-rays because then that's more exposure to the person. But unfortunately, because you're going so fast, yes, you don't use a lot of gas. And yes, sorry, I drew up my little sun up here because also to heat exposure, I'm kind of comparing that to X-ray exposure. I'll explain that right now. So you're driving so fast and using a little X-ray, but again, you're not going to be able to see the details of the trees and the houses and stuff like that. You know what I mean? So even though you get to your destination fast, or you're using fast X-rays, or you're using less X-rays, again, you're not going to be able to see the picture the way that you want to. Okay. So now let's imagine we drive slow. Okay. So now we're going slow. Alright. So now we're driving slow in the car. So now imagine you're driving slow. What's going to happen? You're going to use a lot more gas, right? So again, remember that you're comparing the gas to X-rays, okay? You're going to use a lot less, you're going to use a lot more X-rays because you're going a lot slower, but guess what? You're going to be able to see all the details that you're driving by. You're going to be able to see that there's a person standing, like right here, and we draw a little man right there, and like you're going to see a little squirrel right here and a dog here. You start seeing the colors of the leaves. You start seeing all these details because you slow down. So imagine you slow down the X-rays, you slow down the car, you're going to see a lot more detail. But the problem is you're going to use a lot more gas. You're going to use a lot more X-rays. Okay? But then again, like I said, you're going to be able to see a lot of the detail. Now, now the thing about this, and this is what we're always trying to avoid, is my cool little son over here, is the amount of exposure that the person gets. Now imagine in the high, okay, let's go back to the high. Imagine high, once again, you're going fast, okay, you're using a lot less X-rays, okay, but you're getting blurry on your scenery as you're driving by. But the problem is that imagine your air conditioning and your car is broken, okay? You have to roll down the windows to let the air hit you. Because you're driving fast and using a lot less gas, okay, you're going to end up getting some wind hitting you, and you're going to be able to cool down. So that means less heat to you. That means less X-rays, less exposure to you, which is going to be a great thing. But again, at the sacrifice of having bad view of the scenery, no details, no nothing. Now let's go ahead and let's say we slow it down. Okay, so we slow it down. You're going to be able to see a lot of the view. Okay, a lot of the view on the film, or what you're looking at. Okay, on the car. Again, you're going to end up using a lot more gas. You're going to end up using a lot more X-rays because you're going slow. But at the same time, again, your air conditioning is broken. You roll down the windows. The wind is not going to be hitting you as much. It's not going to cool you down. So what ends up happening, my little buddy over here is going to heat you up. So you're going to have more heat. You're going to have more exposure to X-rays because you're going slow. So that's one of the the compromises we go back and forth with this. But yeah, quantum model is simply that we're going so fast, okay, using a lot less X-rays, but you're not going to be able to see the scenery. You know, it's going to be very blurry, just like you would on a film. That's creating that noise, that's creating that bad image. But if you end up going a lot slower and using a lot more gas, you end up using a lot more X-ray. Of course, you're going to expose the poor patient to more X-ray over, you know, patient exposure, but you end up with a great view of the film. So that's pretty much how quantum model works, and that's kind of like the way that I was able to explain to my kid when he asked me, and he loved it. He was able to understand it. So hopefully this will be able to help anybody else that has any kind of questions about this.
Thank you.